So today I will solve the last example in this topic. This problem is a very easy one. We are looking to draw influence line for reactions at A and B. This is the first step. We have support A, so we have vertical reaction YA, and we have support B, so we have vertical reaction YB. If you would like to draw influence line for reaction YA, go ahead and push support A up by 1. Any other support will remain as it is. The new shape for this beam will be looks like this. Positive, and this is called influence line for YA. Influence line for YB, push support B up by 1. Any other support will remain as it is, no movement. The new shape of this beam looks like this. Positive. That's good. The second part of this problem, we are looking to draw influence line for shear and moment at midspan. Midspan means we have a point here. We can call it C at midspan. So the total span is 40. The total span is 40. So we can say this distance will be 20 feet and this distance will be 20 feet. Midspan at the midpoint, the mid distance. Do you remember? If you would like to draw something else rather than reaction, we need to do some calculations first. By the way, point C will divide the trip between A and B. Do you remember this story? Your truck is moving from A to B. Point C divided this trip to two parts. The first part from A to C. The second trip will be from C to B. Let's remember, if your truck is moving on this part, I don't like this part because I don't like vehicle. So I decided to use the other part of the beam. The other part of the beam looks like this. Here is a cut. Here is reaction YB. At your cut, we have vertical shear will be like this. Would like to make this part to rotate clockwise. And we have moment, would like to make this part to smile. So we have MC and we have shear at C. Go ahead and apply summation f of y equals 0. You will find VC will be negative YB. And you will find, if you take moment at C equals 0, you will find MC equal 20 YB, because this distance will be 20. The next trip, your truck is moving on the other part of the beam from C to B. I don't like this vehicle. I don't like this part of the bridge. So I decided to use the first part. We have vertical reaction here, YA. At this cut, we have moment, would like to make this part to smile. We have shear, would like to rotate this part clockwise. If you apply summation f of y equals 0, you will find VC equal positive YA. If you take moment at C equals 0, you will find MC equal, this distance is 20, so it will be 20 YA. So let's start. I should draw here influence line for shear at C, and probably I need more, so I will use this one for influence line for moment at C. Anyway, let's see. From A to C, from A to C, I'm looking for negative YB. Where is YB from A to C? From A to C, here is YB. By the way, this value will be 0.5. This value will be 0.5. We need this triangle to be multiplied by negative and put it here. Okay? So this triangle, which is positive, times negative, will be like this. 0.5. From A to C. From C to B, we are looking for YA positive. From C to B, here is YA. This part of the triangle is positive. Please keep it positive. Use it as it is. So we will have a triangle here. This value will be 0.5 and will be positive. So the new diagram can be called influence line for shear at C. For moment at C, we will repeat. From A to C, we are looking for YB times 20. From A to C, here is YB. Go ahead and multiply this triangle by 20. The same triangle, because this one is positive, this one will be positive. We didn't change the sign. But this value is 0.5 times 20, this value will be 10. From C to B, we are looking for YA times 20. Here is YA from C to B. Multiply this triangle by 20, you will have another triangle here, and this value will be 10 also, positive. Okay, we are done with the first part, which is influence line for reactions. The second part, influence line for shear and the moment at a certain point, which is at mid-span. The third part, we need to calculate the maximum positive effect for reactions and the shear and the moment at the mid-span due to the given series of fluid. We have this shape. We have this shape, 20 kip, and the spacing between the two forces, 8 feet. Before going through this, I would like to go back to the previous week to explain something. Sometimes the moving, we covered before last meeting, what is the effect if you have dead load and the live load, and I told you, if you have dead load, we don't have a choice. No choice. The dead load must cover the whole bridge. For live load as a distributed load, okay, we have a choice to put live load here or there or whatever based on this diagram, if you would like to get maximum positive or maximum negative. What about if the moving load is truck? The contact between this truck and this bridge will be through this point and this point and this point only. So what makes sense is this truck will be represented by 3 concentrated load. We cannot represent these trucks by uniform distributed load, something like this. Do you know why? Because the truck has only 3-point contact with the bridge. For this truck, for example, we have only 2 points. So the only model can be used is we will represent this truck by series of concentrated load. So for this example, we have 3. For this example, we have 2. Let's see. If we are looking for maximum positive for reaction YA, if you go back to the previous meeting or previous week, influence line for YA for this part will be like this. Negative, positive. If you would like to get the maximum positive effect of this truck, do you know where can I put this truck on the bridge? We need to make sure that this concentrated load and this concentrated load and this concentrated load on the positive diagram. The second part, I need this concentrated load at the maximum value of the diagram. So I will put the first concentrated load here, the second one will be here, the third one will be there. Remember, keep it in your mind. The horizontal distance between these concentrated forces are known and constant. I cannot change the distance between this point and this point because I have to follow the dimension of this truck. So if you put the first concentrated load here, it will be multiplied by this value. If you put this concentrated load here, it will be multiplied by this value. If you put this concentrated load here, it will be multiplied by this value. So the maximum value, which is maximum positive, for reaction YA, it will be this force, F1, time 1, or whatever this value, 1, plus this force, F2, time this value, which is 1, plus F3, which is this force, time this value, I'm not sure how much, so let's say it Y. So the final value will be the maximum positive reaction YA due to the effect of this truck. One more time. Let's see if we have this one influence line for reaction YA. It will be looks like this. Negative, positive, 1, 1. How can I put this truck to get the maximum positive effect? I will put the first wheel here, and we have fixed distance, so the second wheel will be here. So if you would like to get the maximum positive effect of reaction YA, it will be F1 time 1 plus F2 time this value will be 1 also. So I can get the value. So just to give you a hint, if you remember the first meeting with you in this topic, just a reminder, it was this one, I think, yeah. I told you we have different types of truck. Which one I will use? I told you we will not use any of them, but we will use unit load. So we draw influence line for YA due to unit load. We learned this. What will happen if you have this type of truck, or this type of truck, or this type of truck, or this type of truck? Okay. The next step, any kind of truck will be represented by series of concentrated load. Go ahead and put this truck on the bridge and make sure you are putting this truck at the maximum values for the diagram. Do you think if I put the two concentrated load here will be worst? No, because this concentrated load will be multiplied by this value and this value, which are very small, related to 1 and 1. So I decided to put the two concentrated load here. So I decided to put the truck at this position. So right now, I know what is the type of truck, what is the weight of truck, what is the dimension of truck. So I can convert this influence line, which is due to unit load, to a value due to this truck and any other truck. So whatever the type of truck, I can convert right now what is the effect of this truck on the bridge. Let's do this calculation by using this example. So right now, I am done with the influence line for reaction YA, reaction YB, influence line for shear at C, influence line for moment at C. All of these diagrams due to unit load. The third step, we need to calculate the maximum positive effect for reaction and the shear and the moment at mid-span due to the given series of load. Do you know what is the meaning of this series of load? We have a truck, looks like this. This truck has two concentrated load because we have two axes of wheels. The first wheel or the front one with 20 kip, the rear one with 20 kip. The distance in between is 8 feet. Can you tell me how can I put this truck on this bridge to get the maximum positive effect for reaction YE? Just to remind you, influence line for reaction YA was something like this. Here is 1, here is 0, positive. So I decided to put the first wheel of the truck here. The second wheel, no choice, must be at a distance 8 feet. I don't have a choice. If you decided the first wheel, so the second wheel must follow the first one by 8 feet. So the maximum positive value for YA will be 20 kip time this value of the diagram, 1, plus 20 kip, the second wheel, time this value of the diagram. Do you know what is the value here? This distance is 8. So the remaining distance will be 32 because the total distance is 40. Can you make triangle similarity? Then I can figure out this value. I can do it here. 32 divided 40. It will be 0.8. So I will multiply 20 by 0.8. Then the final value will be 36 kip. So guys, believe me, if you have this truck moving on this bridge for any position, for this truck on this bridge, the worst case to give you a maximum reaction at YA, it will be 36. This is the worst case. This reaction is the maximum, 36 or less. We can expect less, but we cannot expect more than 36 as a reaction at YA. One more time. Influence line, the maximum positive effect for reaction at YB. Influence line for YB, just a reminder. YB was something like this. Here is 1, here is 0. It was like this, positive. So I decided as engineer, based on the drawn diagram due to unit load, I found the maximum value for this load is here. So I decided to put the first wheel of the truck at this location. That means the next wheel, no choice, at a distance 8 feet. So I decided to put the second one here. So what is the maximum effect of this truck on reaction YB? Maximum value will be the first 20 times 1. So 20 times the corresponding value, 1, plus the second wheel, which is 20, times the corresponding value, which is 0.8. It will be 0.8. How can I get the 0.8? Okay, go ahead and put your dimension 8 feet. The remaining dimension will be 32. Set up two triangles which are similar, and you can figure out this value will be 0.8. So the value will be 36 kip. So I am done with maximum positive effect for reaction. What is the maximum positive effect for shear? Okay. Influence line for shear at C. Do you remember what was the influence line for shear that I drew 1 minute ago? This one, I would like to repeat it here. It was something like this. And this one is negative and this one is positive. We are looking for maximum positive effect. To get the maximum positive effect as engineer, I decided to put the truck on this side of the bridge. By the way, this value was 0.5, this value was 0.5. I decided to put the truck on this side of the bridge, on the side with positive diagram. So the maximum effect will be the first load 20 times this value, corresponding value will be 0.5. Plus, I don't have a choice. The second wheel must be at distance 8. So this distance will be 8, and the remaining distance will be 12. Remember, the total span is 40. So this mid span will be at 20. So if this wheel at distance 8, the remaining one will be at 12. So can you tell me what is the value of the diagram here? By triangle similarity, I can tell you. 12 divide 20 times 0.5, it will be 0.3. So 20 the second wheel times 0.3. So the final value will be 16 kip. So believe me, if this truck is moving on this bridge at any position, the worst case for shear at C, it will be 16 kip. No way, don't worry. If you design this bridge at point C on this 16, we are safe against any movement of this truck. The last one, maximum positive effect for moment at C. Just a reminder, influence line for moment at C was something like this. This value here was 10, I think. Do you remember this? Yeah, it was 10. Triangle like this. So I decided to put the first wheel here. So at distance 8, from this side or this side, whatever, I have the second one. So the maximum positive effect of MEC, maximum positive effect, equal this value of wheel 20 times the corresponding value from the diagram, which is 10, plus the second wheel 20 times the corresponding value. What is the corresponding value here from the diagram? Okay, go ahead and set up triangle similarity. This distance is 8. The remaining distance is 12. So I can decide what is the value here. It will be 6. So 20 times 6. So we have 320 kfoot. So we have maximum effect for this truck on MC, maximum effect of this truck on shear at C, maximum effect of this truck on reaction YB, maximum effect of this truck on reaction YA. To give you a conclusion, if you have influence line for reaction YA, for example, and I give you dead load, we don't have a choice because the dead load must cover the whole beam. In this case, the maximum or the effect of dead load will be the value of dead load time area of influence line diagram. The value here time this area. For live load as uniform distributed load, okay, try to put your live load to get the maximum effect. In this case, the maximum effect will be this value of live load time area of influence line diagram. The same, this value times this area. But if you have live load looks like truck, no, for truck, this truck will be converted to concentrated loads. I'm not sure how many based on the type of the truck. In this case, if you would like to get the maximum effect, we have different story. This force F1, this force is F2. For example, I will say F1 is corresponding to this value, Y1. This force is corresponding to this value, for example, Y2. So if you would like to get the maximum effect, I will multiply F1 times Y1 plus F2 times Y2. So we would like to first position this truck to get maximum effect. So we need to increase Y1 and Y2. So what do you think? I believe I will move this truck back a little bit to make sure that F1 will be here and F2 will be here. Because F1 and F2, the weight of the truck are constant. So we need to multiply them by maximum value from the diagram. So we need to locate the truck at the position that can give us maximum effect. So please, if you have a problem, you have to read it carefully. If you have dead load, if you have live load as distributed load, it will be more easy. But if you have a truck with concentrated load, we need to think a little bit. Where can I put this truck to give me the maximum effect? As we see here in this problem, first step, we need to draw the influence line for diagrams, which are required by the problem. The second step, we need to position the truck to give you higher values from the diagram. Then I can get the maximum effect for shear, for moment, and for reaction. Any question regarding this point? Any question regarding this point? Okay, let me ask you a question. If I have a beam like this, we have here hinge, we have here roller, and we have here pin connection. Influence line for reaction YB. This one is A, this one is B, this one is C. I think the influence line for reaction YB will be like this. Here is the connection. If you push support B up by 1, any other support will remain as it is. I believe this part of the beam is 1 unit. It will be like this. That makes sense? Because I pushed support B up by 1 and the support C as it is. So the new position of this red line will be like this. Negative, positive. Because you have here connection and this point does not move, so I think the new position of this one looks like this. Anyway, so this one can be called influence line for reaction YA. If we have dead load, what is the distribution of dead load? No way. The dead load must cover everywhere of the bridge. Dead load. If we have live load and we need to get the maximum negative effect, maximum negative effect, do you know where can I put the live load? Anybody can tell me where is the distribution of live load to get the maximum negative effect on reaction Y? I'm sorry, this reaction influence of reaction YB. YB? Anybody can tell me? Thank you. Thank you, Ben. Yes, I will put only live load here. If we assume this live load, which is distributed as people, pedestrians on the bridge, to find the maximum negative effect, okay, I will ask the people to move to this side of the bridge only. And the remaining part of the bridge is empty, then we are in the worst case to give the maximum negative effect. Okay, can you tell me what is the worst case for these people to give you maximum positive effect? Okay, I will move people on the bridge to cover only this part. Believe me, if you have people covering this part of the bridge, you are in the worst case to give you maximum positive effect on YB. That makes sense? What will happen if we would like to figure out where can I put my truck? I have a little truck like this to get the maximum negative effect on YB. Do you know where can I move this truck on the bridge to get the maximum negative effect of YB? Yeah, I think if I moved this truck to be here, if I put the truck at this end of the bridge, not here, I believe this position will give me maximum negative effect on YB. Can you tell me where can I put this truck to get the maximum positive effect of YB? I believe I can put this truck here. This is the maximum value of the diagram. That's right. So I will put the first wheel here, and then the next wheel here. So my truck will be in this position, will give me the maximum positive effect. Do you know why? Because this wheel, this load will be multiplied by this value. This value of the load will be multiplied by this value. So I can get the maximum value. So if you are moving on a bridge, if you are living in Dallas, we have many bridges there, and you have traffic jam, go ahead and try to draw influence line for this bridge and expect where is the maximum or the worst case of the people or trucks, and ask cars to move this way or this way to avoid any worst case. So you are a bridge engineer right now. So guys, believe me, I cannot decide which part I will put the live load, like distributed load, or where can I put the truck without influence line D2 unit load. If you can draw this diagram correctly, you can do your calculations more easy. That makes sense? That makes sense? Any question? Do you have any question? If you have any question, please let me know. I have few comments. Okay, go ahead, Jennifer. Do you have one? Okay. If I have a beam like this, A, B, C. So we have a beam with 2 units. This part is 1 unit. Must remain straight all the time. And we have another part, which is this unit. The 2 parts are connected together at this point by pin connection. If you decided to draw influence line for reaction YA, what will happen? Influence line for reaction YB, what will happen? Influence line for reaction YC, what will happen? I know this problem is very easy. It's not my target, but let me explain it first. Influence line for reaction YA. First step, move support A up by 1. No movement at this support, no movement at this support. Okay. If there is no movement for this support and this support, this part will remain without movement. Does that make sense? This side of the connection didn't move, the other side will not move, the new position of this part looks like this. Influence line for YB, push support B up by 1. Any other support without movement. Okay? If this point as it is, if this point moved up, I think this part will remain a straight line like this. Do you agree? This side of the connection moved up, the other side will move up, so the new position of this part will be like this. On flance line for YC, push support C up by 1. Any other support without movement. Let's see. If this point moved up and this point as it is, this part of the beam must remain straight. It will be like this. This side of the connection moved down, the other side will move down, so the new position of this part will be like this. Guys, please give me a feedback 100%. Do you agree with what I did? Do you have any question or any concern or something is not clear for you for what I did? Because if you can understand these 3 diagrams, you are in a good track. You are in a good position for this topic. So guys, do you have any concern about anything that I covered just a second before for on flance line of YA, YB, YC? No, we don't have fixed. We have hinge. Fixed is a different story. We have roller and we have roller. If you have fixed like this, for example, so keep in your mind, in this case, we have 2 parts, this part and this part. Your left part is a special case because it's attached to fixed support. And this one is roller. Let's try this one. If we would like to draw on flance line for reaction, this one is A, this one is B. On flance line for reaction YA. And also on flance line for reaction MA. And also on flance line for reaction YB. Okay, just put your reactions first. We have reaction here YA, we have reaction here MA, we have reaction here YB. Push your support A up by 1. Remember, you are pushing a fixed up. If you're pushing a fixed support up, the fixed will move up and the attached part will move up with the same value. Because fixed is a special case. And the part attached to this fixed must follow this fixed support if you move it up by 1. Any other support will remain without movement. What will happen? Okay, at this connection, we have 2 sides. The left side moved up, following this part. The right side must move up with the same value. So the new position of this part will be like this. Negative, positive. On flance line for MA. Do you remember how can I draw on flance line for moment at fixed? Rotate this fixed by theta equal 1 in the same direction of the assumed moment. And this assumed moment would like to make this part to smile. If you rotate this fixed, this part will remain perpendicular. So it will rotate like this. And this point didn't move. For the connection, this side moved down, the other side must move down, so the new position will be like this. Positive and negative. Influence line for YB, push support B up by 1, any other support without movement. Guys, if you didn't do anything to the fixed, no movement, no rotation, nothing, so the fixed will remain and the attached part will remain without anything. This side of the connection didn't move, the other side will not move. So we have a point here, we have a point here, this part will be like this. Must straight line, positive. This is called influence line for YB. Any question for this example so far? Any question? Okay. I don't need to cover this because I covered all of these diagrams before. What I need to do is, for this example, what is the influence line for shear at E? What is the influence line for moment at D? For this one, what is the influence line for shear at A? What is the influence line for moment at C? I'm sorry? What do you mean? I mean in a different way. What is the influence line for shear at support? I'm sorry, at edge support. Support at the beginning of the bridge. What is the influence line for shear at this support? It's not any support. No, I'm talking about edge support. Support at the beginning of the bridge. The second one, what is the influence line for moment at the pin connection? Sometimes in the exam or quiz or something like this, I will ask you this question. What is the influence line for shear at edge support? What is the influence line for moment at pin connection? Anybody can help me to draw influence line for shear, or do you have any idea or any feedback about shear at A? We can call it like this: shear at A or moment at D. Any answer? Do you have any answer for this point? Okay, let me start first with influence line for moment at D. Pin connection. Pin connection. Any pin connection, we don't have moment. I'm sorry. So if I'm asking for influence line for moment at D, 0. We don't have diagram. We don't have influence line. We don't have values. Because at any position of any truck, any dead load, any live load, anything for this connection, which is pin connection, we don't have moment at all, at any time, for any situation. We don't have moment. So be smart. If I'm asking for influence line for moment and at a point, and this point is pin connection, don't think. It's 0 without thinking. It's 0. Any pin connection, we don't have moment because you can rotate this pin connection. We expect that this pin connection will be in somehow, will be like this, or will be like this. So we don't have moment, cannot support moment. Any question for this point? Keep in your mind, if I'm asking for unfluence line for moment at a specific point, and this point is pin connection, we don't have diagram. You have to say 0. You have to say 0. You have to say 0. If I'm asking for unfluence line for shear at edge support, the unfluence line for this shear will be the same like unfluence line for reaction at this support. So unfluence line here in for reaction YA, it will be the same for unfluence line for shear at A. Same diagram. Same diagram. Unfluence line for reaction at edge support. I am clear in this point. I'm not saying at any support. It's a different story. Unfluence line for shear at edge support equal unfluence line for reaction at this support. One more time. For this example, unfluence line for moment at C. C is a pin connection, will be 0. Unfluence line for shear at A. A is a support. At A is edge support. So unfluence line for shear at A will be unfluence line for reaction at A also. So this diagram, which is unfluence line for YA, will be unfluence line for shear at A also. So during the exam, probably I will ask you about shear or moment at edge support or pin connection respectively.